Hi, all. Good morning. So, can you please confirm my voice is audible or not?
Yes, sir, it's audible.
Okay, I hope my screen also visible to everyone.
Yes, sir.
Okay. Okay, so as session, we discussed about data warehousing architecture and we discussed about types of data warehousing architectures. And in this process, we discussed about what is the data mart and we discussed about what is the top-down approach and what is the bottom-up approach. And we started discussing about ER modeling and we discussed about dimensional modeling. Within the dimensional modeling, we discussed about what is fact, what is the dimension, and we discussed about what is the fact table, and we discussed about what is the dimensional table, and we discussed about what is meant by dimensional keys. Okay, so all these are the different topics we covered as part of our yesterday's session. Now today we'll continue with the other topics. Now actually as part of dimensional modeling, so just we'll try to recap. What is the dimensional modeling? What is the dimensional modeling?
Which contains a
In
descriptive
dimensional
data.
modeling, we are having centralized fact table, which is surrounded by multiple dimensional tables. So yesterday we discussed about in the dimensional modeling, we are having the centralized table, which we can able to call it as a fact table, which is surrounded by the child tables, or which we can able to call it as a dimensional tables, that we can able to call it as a dimensional modeling. Now with the dimensional modeling, we are having two types of schemas. First type of schema we can able to call it as nothing but star schema, and the second type of schema we can able to call it as nothing but snowflake schema. So we are having the two types of schemas. One we can able to call it as a star schema. Second one we can able to call it as a snowflake schema. As part of yesterday's example, whatever the dimensional modeling topics we discussed by using the diagram, that kind of schema simply we can able to call it as nothing but star schema. Just I will show you the diagram, yesterday's diagram. Okay. So yesterday we discussed about the star schema. So in the star schema, yesterday we discussed about the dimensional modeling. In the dimensional modeling, what we discussed, we are having the centralized fact table, which is surrounded by the multiple dimensional tables. Initially, we started discussing about we are having the centralized table, which is surrounded by the multiple tables. After that, we discussed that we are having the centralized table, which we can able to call it as a fact table, which is surrounded by the multiple child tables, which we can able to call it as a dimensional table. So this we can able to call it as nothing but dimensional modeling. But if you observe here, how it is looking like indirectly, is looking like a kind of a star. So whenever we are representing our dimensional modeling like this with the centralized fact table with the surrounded dimensional tables, such kind of schema simply we can able to call it as a star schema. In the dimensional modeling, whenever we are going to have the centralized fact table which is surrounded by the multiple dimensional tables like this, such kind of schema simply we can able to call it as nothing but star schema. Okay, now in the snowflake schema also we are going to see all the contents in the same way, but there is a small difference in the snowflake schema only. In the snowflake schema, what will happen is we will see sub-dimensional tables. So in the star schema and snowflake schema, in the both the schemas, we are going to see in the both the schemas, we are having the centralized fact table, which is surrounded by the multiple dimensional tables. In the star schema, we are having the same concept. In the snowflake schema also, we are having the same concept, because the star schema and snowflake schema both are falling under the dimensional modeling. As part of dimensional modeling, either if you are going to follow the star schema or if you are going to follow the snowflake schema, we are going to have the centralized fact table, which is surrounded by obviously our multiple dimensional tables only. But in the snowflake schema, there is a small difference here. What is going to happen here? We can able to see the sub-dimensional tables, which is nothing but whatever the dimensional table we are having, on top of this dimensional table, we can able to see sub-dimensional tables. For example, if you remember, yesterday we discussed about time dimensional table. In this table, we are going to maintain the columns as time ID column, year column, month column, and day column. So these are the columns actually we are going to see in the time dimensional table. Now sub-dimensional table is nothing but here I will create a sub-dimensional table with year underscore dim. Here I will maintain year ID column and only year column. In the same way, I am going to maintain day underscore dimensional table. In this, we are going to maintain day ID column and day column. In the same way, we are going to maintain one more table called as a month underscore dimensional table. In this, I will maintain month ID column and month value. So this is the way what I'm doing here. Whatever the main dimensional table we are having, instead of having all these columns in this main dimensional table, I am going to create the sub-dimensional tables like this. For example, year dimensional table which is going to contain year values. Day dimensional table which is going to contain day values. Month dimensional table which is going to contain the month values. Indirectly, we are dividing one dimensional table into the multiple sub-dimensional tables. And now, whenever we are going to maintain the sub-dimensional tables in the dimensional modeling, that kind of schema simply we can able to call it as nothing but snowflake schema. In the star schema, we are not going to see the sub-dimensional tables, but in the snowflake schema, we are going to see the sub-dimensional tables. Okay, just I will show you the diagram. With that, you can able to get the clear picture. If you observe, in the star schema, what is happening as we discussed, you are having the centralized fact table which is surrounded by the multiple dimensional tables. It is looking like a star. For that reason, just we can able to call it as a star schema. But if you see the snowflake schema, what we discussed, we are going to see the sub-dimensional tables. For example, in this diagram, I'm showing you that we are having the dimensional table 3. On top of this dimensional table 3, we are creating dimensional table 3, one sub-dimensional table, dimensional table 3, two sub-dimensional table, dimensional table 3, three sub-dimensional table. Like that, we are dividing one dimensional table into the multiple sub-dimensional tables. Whenever we are going to maintain the multiple sub-dimensional tables in the dimensional modeling, that kind of schema simply we can able to call it as a snowflake schema. But if you observe here, in between both the schemas, what is the common thing? In between star schema and snowflake schema, what is the common thing? You are going to have the centralized fact table which is surrounded by the dimensional table. Indirectly, our basic concept is completely same and don't get any kind of confusion. Only extra thing here is nothing but we are going to maintain the multiple sub-dimensional tables as part of our snowflake schema. If you are not going to maintain the multiple sub-dimensional tables, such kind of schema we can able to call it as a star schema. Whenever we are going to maintain the multiple sub-dimensional tables by depending on the requirement, such kind of schema simply we can able to call it as a snowflake schema. And if we observe here both the diagrams, and in this diagram from the fact table to dimensional table, what kind of relationship we are having? It's a kind of a one-to-one relationship. Fact table to dimensional table 1, fact table to dimensional table 2, fact table to dimensional table 3, fact table to dimensional table 4. Like that, you are having the one-to-one relationship, or we can able to call it as a direct relationship only. But coming to snowflake schema, what is going to happen? Because of having the multiple sub-dimensional tables, here we can able to see the one-to-many relationship, or we can able to see the indirect relationship between our fact table to dimensional table. These are few differences we can able to tell between the star schema and snowflake schema. In the star schema, we are having the one-to-one relationship, or we are having the direct relationship. But coming to snowflake schema, we are going to see the one-to-many relationship because of having the more dimensional tables and because of having the sub-dimensional tables. At the same time, here we can able to see the indirect relationship. But coming to star schema, we are going to see the direct relationship only. And in the star schema, are we going to maintain the sub-dimensional tables? No. In the snowflake schema, we are going to maintain the sub-dimensional tables. These are the differences we can able to give between the star schema and snowflake schema. I will type here. In star schema, we are going to have centralized fact table, which is surrounded by multiple dimensional tables. And we are not going to maintain any sub-dimensional tables. Comment here, we can able to say the snowflake schema. We are going to have centralized fact table, which is surrounded by multiple dimensional tables. And here we are going to maintain sub-dimensional tables by depending on requirement. So just I want to repeat one statement, whatever we discussed yesterday. Now tell me, who will decide whether we need to go with the star schema or snowflake schema? Is it the responsibility of the data engineer or it is the responsibility of the data modelers?
Data modelers are
See,
architects.
all these topics are comes under the dimensional modeling. All these kind of decisions and all these kind of activities are going to perform by your data modelers in our real-time project study. But if you are going to work as a data engineer, you should have some minimal understanding about the modeling concepts. For that reason, we are discussing about all these kind of topics study. But don't think that how I need to decide whether we need to go with the star schema or we need to go with the snowflake schema. All that is the headache for our data modelers. That is not the headache for the data engineers study, but in the requirement document they are going to specify in this project we are going to use the star schema, or they are going to specify in this project we are going to use the snowflake schema. Whenever we are going to see such kind of statements, you need to understand what is happening as part of the star schema, what is happening on top of the snowflake schema. For that reason, we are trying to understand what is the dimensional modeling, what is the star schema, and what is the snowflake schema. Again, coming back to star schema and snowflake schema, both are completely same. Only thing is nothing but in the snowflake schema we are going to maintain the sub-dimensional tables, but coming to star schema we are not going to maintain the sub-dimensional tables only, except that all remaining concepts are same between the star schema and snowflake schema. And yesterday we discussed about a few concepts called as the dimensional keys only. Try to give the answer. What is the meaning of dimensional keys? What is meant by dimensional keys? Or in which table we are going to see the dimensional
fact
keys?
table we can see in dimensional keys.
Yes, perfect. So in the fact table, we are going to maintain the fact values. Other than fact values, we are going to maintain the dimensional keys. Now tell me, what is the purpose of the dimensional key? What is the purpose of the dimensional keys?
Relation
To
maintain relationship between the fact table to your dimensional tables. We have to maintain some foreign keys into our fact table. Instead of calling it as a foreign keys, we are calling it as a dimensional keys as part of our dimensional modeling. Okay. Now, as part of the star schema and snowflake schema also, in the fact table, obviously we are going to maintain the dimensional keys. With the help of the dimensional keys only, you are going to maintain the relationship with our dimensional tables, or we are going to maintain the relationship with our sub-dimensional tables only. This is the way we need to understand what is the star schema and what is the snowflake schema. Okay. Any questions up here, please ask me.
Sir, in few use cases, we found that result summary, right? That is the final table we created, result summary. So can we call that is the fact table?
Yes, perfectly. That is the fact table, because in that table, what we are maintaining, we are maintaining the total purchase amount. So for the batch 19 people, we are creating one table called as a result summary as part of our use cases only. In the result summary, we are going to maintain the total purchase amount. That is the one of the measurable value. So we can able to call that is nothing but indirectly our fact table. But in that table, we are not maintaining any dimensional keys only, but generally we are going to maintain the dimensional keys on top of the fact table. In that use case, we are not maintaining any kind of dimensional keys on the fact table, but because of having the fact values, we can able to call the table is nothing but our fact table.
Yes, sir. Thank you.
Okay. Yeah. Now we'll try to understand what are the different types of dimensional tables we are having. So we are having the different types of dimensional tables, and the first type of dimensional table we can able to call it as nothing but conformed dimensional tables. We'll go one by one. So first we'll try to understand what is the meaning of the conformed dimensional tables. Just observe here. If two fact tables are going to have relationship with same dimensional table. So yesterday we discussed about one statement. In the real-time projects, we are going to maintain the only one fact table, or we are going to see the multiple fact tables. In the real-time projects, are we going to see only single fact table, or we are going to see the multiple fact tables?
Multiple.
Obviously, we are going to see the multiple fact tables. Here I am given the statement like this. When you are going to maintain the multiple fact tables, if two fact tables are going to have relationship with same dimensional table, such kind of dimensional table, we can call it as conformed dimensional table. if two fact tables are going to have relationship with the same dimensional table, such kind of dimensional tables we can able to call it as nothing but conformed dimensional tables. And just I will show you one example, you can get a clear picture. You see here. So here I am having the fact table 1 surrounded by multiple dimensional tables. Here I am having, for example, second fact table. It is also surrounded by multiple dimensional tables. And now if you observe here, fact table 1 is having relationship with the dimensional table 1. And fact table 2 also having the relationship with the dimensional table 1. Indirectly, we are having the two different fact tables in my project, for example. Now, these two fact tables are having relationship with the same dimensional table. Fact table 1 having relationship with the dimensional table 1. Fact table 2 also having the relationship with the dimensional table 1. So in this situation, whatever the dimensional table we are using commonly between the both the fact tables and such kind of dimensional table, simply we can able to call it as a conformed dimensional table. Now you tell me, can we able to call D2 dimensional table 2 as a conformed dimensional table? Can we call dimensional table 2 as a conformed dimensional table?
No.
Obviously no, because fact table 1 having the relationship with the dimensional table 2, but fact table 2 is not having any relationship with the dimensional table 2 only. For that reason, you cannot able to call dimensional table 2 as a conformed dimensional table. For example, just I'm doing small modification. Now see, fact table 1 having the relationship with the dimensional table 4. Fact table 2 also having the relationship with the dimensional table 4. Now what we can able to call the dimensional table 4? What we can able to call this dimensional table 4? Obviously, we can able to call it as a conformed dimensional table because fact table 1 having the relationship with the dimensional table 4. Fact table 2 also having the relationship with the same dimensional table. If we are using the same dimensional table across multiple fact tables and such kind of dimensional tables, we can able to call it as nothing but our conformed dimensional tables. In this example, I am giving only one conformed dimensional table, which is nothing but dimensional table 1. Fact table 1 having the relationship with the dimensional table 1. Fact table 2 also having the relationship with the dimensional table 1. For that reason, this dimensional table we can able to call it as nothing but conformed dimensional table. Okay. Actually, in the real time projects only, in real time projects, or I can able to say in real time, in most of the projects, we can see one dimensional table called as time dimensional table. So in the real time, in most of the projects or in all the projects, we are going to see one common table called as nothing but time dimensional table, or we can able to call it as a calendar underscore dimensional table. This is the one of the common table we can able to see across all the projects only. Now you try to give the answer any cases. In this time dimensional table, what data we are going to maintain? Any cases? We are going to maintain our time related data. Now, for example, here we are going to have the time ID column as we discussed earlier. Here we are going to have the year column, and we are going to have the month column, and we are going to have the day column. And after that, here we can able to see one more column as week number, and we can able to see one more column called as a quarter number, and we can able to see one more column as a day of the year. So like this, in this table, we are going to maintain all the data which are related to your time information. For example, I am having the first time ID like this, 2023-09-01. For example, like this is the time ID column. Now for this, what will happen is we can able to see the information like this, and the year is having value as a 2023. Coming to month, we can able to see it as a 09. Coming to day, it's showing value as a 01. Week number, just I'm giving the generic value. So this week falling under which week? So I'm giving, for example, this is the 34th week. Quarter, for example, I'm giving it as a 3. And day of the year, for example, I'm giving it as a 268 or 269. So like this, what is going to happen? For this time ID, what is the current year? What is the current month? What is the current day? What is the current week number? What is the quarter number? What is the day of the year? All this kind of information we can able to see on top of your time dimensional table. In most of the data warehousing projects, commonly we are going to use the tables called as a time dimensional table, or we can able to call it as a calendar dimensional table. Now you try to give the answer. Why in most of the data warehousing projects we are going to use this table only? Any guesses? Why in most of the data warehousing projects we are going to use this table as a common table? Very simple. In data warehousing projects, we need to perform analysis. We are going to perform analysis for current data plus historical data, or we can able to call it as a previous data. Indirectly, we are performing all our analysis based on the time information. Current year, what is the sales? Last 2 years, what is the sales? Last 5 years, what is the sales? Indirectly, everything is depending on the time, or everything is depending on the calendar information. That's the reason, to understand all the date informations or to understand all the time information, very commonly we are going to use one table called as a time dimensional table, or we can able to, in some projects we are calling it as a calendar dimensional table. Certainly, now if you observe here I given the one more example. We are having the sales fact table, which is going to have relationship with the time dimensional table. We are having the one more table called as a balance fact table. In this table also having the relationship with the time dimensional table. Now you tell me, in this example, which table we can able to call it as a conformer dimensional table? In this example, in the second example, sales fact table is having relationship with the time dimensional table. Balance fact table is also having the relationship with the time dimensional table. Now, in this example, which table we can able to call it as a conformer dimensional table?
Time dimension.
Obviously, our time dimensional table, because both the fact tables are having the relationship with the same time dimensional table. That's the reason this time dimensional table simply we can able to call it as a conformer dimensional table. Now, actually, what will happen is in the real time, in the requirement document, they are going to specify this table will act as
Hello. Hello.
Sir, we are unable to hear you, sir.
my voice is audible now.
Yes, sir.
Yes, sir.
Okay, sorry, again power cut here, and so for the reason I got disconnected. Yeah, we'll continue. Okay, so we are discussing about here. So in this example, whatever the previous example I'm showing you. So in this example, this time dimensional table is going to act as a conformer dimensional table. Now with the real time process, what will happen is in the requirement document, they are going to specify this table will act as a conformer dimensional table. By seeing the statement, what we need to understand? By seeing the statement, what we need to understand? Whatever the table, they are calling it as a conformer dimensional table. By seeing the statement, we need to understand, okay, this table is going to have relationship with the multiple fact tables. That is the thing we need to understand by seeing such kind of statements on our requirement documents. And for that reason only, just we are discussing about all the different types of our dimensional tables. So conformer dimensional table is nothing but if two fact tables are going to have relationship with the same dimensional table, such kind of dimensional table simply we can able to call it as a conformal dimensional tables. Okay, in the same way, we are going to have the one more type of dimensional table called as a junk dimensional table. We are going to have one more type of dimensional table called as a junk dimensional table. In the name only, you can able to see the answer, and we can able to say if a dimensional table is going to contain all junk values, such kind of dimensional table. We can call it as junk dimensional table. In a particular dimensional table, if we are going to maintain kind of the junk values and such kind of dimensional table, simply we can able to call it as a junk dimensional table. We'll see one example. With that, we can able to get the clear picture. What is the meaning of junk dimensional table? If you see here we are going to maintain one table called as, for example, sales underscore fact table. In this fact table, we are going to maintain the product ID, location ID, time ID. As we discussed earlier, all these columns are going to act as a dimensional keys and the product ID, location ID, time ID. All these columns are going to act as a dimensional keys, and we are having the sales column, which is nothing but our fact value, or we can able to call it as a measurement value. In the fact table, we are going to maintain the dimensional keys. At the same time, we are going to maintain the measurement values, which we can able to call it as a fact value. This table we are calling it as a fact table. In this example, I am using the fact table called as nothing but sales underscore fact table. Okay. Now my requirement is, in this table I want to maintain the two more indicator columns, and in the same fact table I want to maintain the indicator columns like indicator 1 column and indicator 2 column. Indicator 1 is representing whether product is available in the company or not. If product is available in the company, then we need to give the value as a Y. If product is not available in the company, then I want to give the value as a N. So that is the way we are maintaining one indicator column called as a indicator 1 column. In this column, we are representing if product is available, we are giving the value as a Y. If product is not available, we are going to give the value as a N. In the same way, we are going to maintain one more column called as a indicator 2 column. And in this indicator 2 column, we are going to maintain the information for discount availability. If discount is available, we are given the value as a Y. If discount is not available, then we are going to give the value as a N. So this is the way, by using these two indicators, I want to represent whether product is available or not. At the same time, I need to maintain discount is available or not. Now that is the data we are maintaining on top of your fact table. Now you tell me, if you are going to maintain this kind of data in the fact table, what is going to happen? Any guesses? If you are going to maintain these kind of indicator columns on top of the fact table, what will happen? What is the purpose of the fact table? To maintain the fact values and to maintain the dimensional keys and D. But tell me, this indicator 1 and indicator 2, these two columns are comes under the dimensional keys, or these two columns are comes under the measurement, or these two columns are falling into any other category? Any guesses? This indicator 1 column and indicator 2 column, whether these are falling under the dimensional keys, or these are falling under the measurable columns, or these two columns are falling into any other category? Simply we can able to say these two columns are not at all related to our dimensional keys and D. At the same time, these two columns are not at all related to the our fact value. Indirectly, our requirement is we need to maintain the indicator columns. But instead of maintaining these indicator columns in the fact table, what we have to do here is we need to maintain these kind of indicator columns into our dimensional tables and D. Instead of maintaining these kind of indicator columns in the fact table, we need to maintain all these kind of indicator columns into the dimensional table. Now tell me, if you are going to maintain the two indicator columns, how many possibilities we can able to see for both the indicator columns? How many possible values we can able to see? Either both can be Y and Y, or both can be N and N. Otherwise, one is Y, one is N, and other one is N and one is Y and D. Indirectly, total we can able to see the 4 possible scenarios on top of your both the indicator columns. For that reason, I will create a separate dimensional table. In that dimensional table, I will maintain all the indicator columns. Here in this example, you are going to maintain the 4 records only. For every record, I am going to maintain the ID column. Here I will give the ID values as simply 1, 2, 3, and 4. Now, after maintaining this dimensional table, what I will do here is, in this fact table, just I will add a column called as a ID column. Now, this ID column is going to act as a foreign key. Now, for this ID column, what is the primary key? In this dimensional table, we are maintaining this ID column as a primary key. With that, we can able to understand what is the product availability for 101, what is the product availability for 102. All that kind of information we can able to understand with the help of the primary key and foreign key relationship. But in this whole example, if you observe what I'm doing here, instead of maintaining all these indicator columns in the fact table, we are maintaining a separate dimensional table. In that dimensional table, we are maintaining all the indicator values only. Now, whenever we are going to maintain the indicator values into the particular dimensional table, such kind of dimensional tables, we can able to call it as a junk dimensional table. Now, tell me any guesses why we are calling it as a junk? Why we are calling it as a junk? Because in the indicator one, if you observe, we are going to see the duplicate records, multiple duplicate records like YYNN. In the indicator 2 also, we are going to see the duplicate records as YYNN. For that reason, that kind of data we can able to call it as a junk data. Now, we are maintaining all this kind of junk data into the dimensional table. That kind of dimensional table, simply we can able to call it as a junk dimensional table. Try to understand the example. Once you understand the example, it is very easy to understand what is the concept of it. Just I will repeat one more time. As per the requirement, I need to maintain the 2 indicator columns. Instead of maintaining these 2 indicator columns in the fact table, we are going to create a separate dimensional table. In this dimensional table, for these 2 indicator columns, we are going to maintain the values as either Y or N. Whenever we are maintaining only the indicator columns on top of your dimensional table, such kind of dimensional tables, we can able to call it as a junk dimensional table. Now tell me, in this fact table, finally we are going to maintain 2 columns or we are going to maintain only 1 column as the ID column? You try to give the answer. In this fact table, at the end, we are going to maintain the 2 indicator columns or we are going to maintain only 1 column called as a ID column.
Maintain 2 columns. Because of ID1 is separate, where ID2 is separate. ID1 has a product availability, ID2 has a discount.
Yeah, correct. But in the fact table, are we going to maintain these 2 columns or we are going to maintain these columns in the dimensional tables? These indicator columns we are maintaining in the dimensional table. If you are maintaining these indicator columns in the dimensional table, then there is no purpose of maintaining these 2 indicator columns in the fact table only. So what I will do here, instead of maintaining these 2 indicator columns, just I will maintain only 1 column called as the ID column here. Now this ID column is acting as a primary key here. Same ID column is acting as a foreign key into your fact table. Now for example, my requirement is for 101. What is the product availability I want to check? So what I can do here, for 101, what is the ID value? 1. For this ID in the dimensional table, what is the indicator 1 we are having? This value is nothing but Y. Indirectly we can able to say for 101, product is available. How we are giving this kind of confirmation? Product ID 101 is having the ID value called as a 1 in the fact table. For this one, in the dimensional table, we are having the values as indicator 1Y, indicator 2Y. Indicator 1Y is nothing but that product is available in the company. With that, we can able to give the statement for 101, product is available. Now, in the same way, you try to give the answer. For 102, I want to verify discount is available or not. You tell me for the 102 product, discount is available or not.
Yes, discount is available.
For 102 product, if you see here, 102 is the product ID 102. For this 102, what is the ID we are having? 2. For this 2 in this dimensional table, indicator 2 having the value called as a N and D. Now, what is the indicator? This is nothing but discount availability. Coming to discount availability, we are having the value called as a N, which is nothing but for 102, whether we are having the discount or we are not having the discount. We are not having the discount. Indirectly, by using this ID column, we are going to maintain the relationship between the fact table and dimensional table. With that information, you can able to understand whether product is available or not. At the same time, you can able to understand whether discount is available or not. But in this whole example, instead of maintaining indicator columns in the fact table, we are maintaining all the indicator columns into our dimensional table. Just for representation, I given these columns in the red color, which is nothing but these 2 columns we are not maintaining in the fact table. These columns we are going to maintain in the table called as a dimensional table only. Whenever a dimensional table is going to contain all the indicator values, such kind of table simply we can able to call it as a junk dimensional table. Okay. Any question on top of this example? Again, please ask me here. Very simple. Just I'm making it as a complicated by giving multiple examples only. But if you want to understand in the very simplified fashion, we can able to say if your dimensional table is going to contain all the indicator values, such kind of table simply we can able to call it as a junk dimensional table. But if I'm giving directly the statement, you cannot able to understand how we are using the junk dimensional tables in the real time. That's the reason. Just I taken one example called as a sales fact table and dimensional table. With that, I am trying to explain how we are calling it as a junk dimensional tables in our real-time projects. Okay. Now, for example, in the requirement document, they are going to inform that this x_dimensional table will act as junk dimensional table in our project. By seeing the statement, what we need to understand? In the requirement document, simply they are giving the statement, this dimensional table is going to act as a junk dimensional table in our project. By seeing the statement, what you need to understand? We need to understand in this x_dimensional table, we are going to maintain the junk values, which are nothing but we are going to maintain all the indicator values into the table called as a x_dimensional table. For that reason, just we are discussing what is the meaning of the junk dimensional table and what is the meaning of the conformal dimensional table. Okay. Any question on this junk dimensional table? Please ask me here.
Sorry, if a product is available or suppose if product is not available and the discount is not available, we simply call it as a junk table.
No, it's not a junk table. So how we are saying is product is available or not by using the indicator value as either Y or N. And how we are representing discount is available or not by using Y or N. So indirectly, all these values we can able to call it as a indicator values. And for a indicator column, what will happen? Either you can able to see the values as a Y or we can able to see the value as a N. Now, if you are maintaining all these kind of indicator columns into the separate dimensional table, that kind of dimensional table only we can able to call it as a junk dimensional table. Is it clear?
Okay, sir.
Okay. Any other questions? Okay. If no questions, now we'll try to understand one more type of dimensional table called as a SCD tables or we can able to call it as slowly changing dimensional tables. So next 20 minutes or 30 minutes, please put your complete focus on this one because this is the one of the very important dimensional table which we need to understand. And as part of interviews also, they will ask the questions on top of the SCD tables only. That's the reason this is the one of the important concept we need to understand. Please try to focus for next 20 to 30 minutes. So first we'll try to understand what is the meaning of the SCD tables. By using a dimensional table, if we are going to capture all the changes which are happening on the source system. By using a dimensional table, if we are going to capture all the changes which are happening on top of your source system, such kind of dimensional tables, we can call it as slowly changing dimensional tables. Try to understand the statement is here. By using a dimensional table, which is nothing but I am having a dimensional table. By using that table, what we are going to do here, we are going to capture all the changes which are happening on top of your source system. Now you try to give the answer here, where we can able to see the dimensional tables in our dimensional modeling. Now you tell me in which kind of projects we are going to follow the dimensional modeling? In data warehousing projects. Now, in the data warehousing projects only, what is the source system? This one you try to give the answer. In our data warehousing projects, what is the source or what is the source system?
ODS is just.
Yeah, perfectly correct answer. So ODS only. Now, indirectly, what I'm telling, by using a dimensional table, if we are going to capture all the changes which are happening on top of your source system or on top of your ODS only, such kind of dimensional tables, simply we can able to call it as nothing but SCD tables, or we can able to call it as a slowly changing dimensional tables. Now, just we'll take one example. By using the example, we'll try to understand what is the meaning of all the statement, what is the meaning of capturing the changes, and what is the meaning of the source system. We'll try to understand by using an example. With that, you can able to get a clear picture. Just observe here. Just observe. So this is the ODS. Yesterday we discussed about the data warehousing architecture. In the data warehousing architecture, what we can able to see, you are having the ODS. On top of ODS, we are going to build the staging database. On top of staging database, we are going to build our data warehouse system. So this is the architecture of our data warehouse only. In the data warehouse, we can able to see the ODS, then we can able to see the staging database, and then we can able to see our data warehouse system. Now, in the ODS, what we are going to see, we can able to see all the source data in the text file format or in the JSON file format, or we can able to see it in the XML format. Now in the staging database, we are converting all this data into the tabular format. On top of that, we are going to build our data warehouse system. Now, in the ODS, on the day one, so we are having a file called as the e.text file. On day one, in this file, we are having total 3 records like this: EID column, ename column, and location column. And we are having the values as EID 123, ename ABC, and location showing it as a Hyderabad, Chennai, and Vizag. Now, what we will do here on the day one, whatever the data we are getting in the ODS, that data we are loading into our staging database, the table called as, for example, STG_ENV table. In this table, I am loading all these values on day one. Coming to day one, how many records we are getting? We are getting only 3 records only. So we are loading only those 3 records on top of your staging table. Now, whatever the data we are loading in the staging table, I am loading all the data into my data warehouse system table. In the data warehouse, for example, we are having the dimensional table called as a EMP dimensional table. In this table, we are loading all this data as is, which is nothing but on day one, we loaded the data from the ODS to staging and staging to our data warehouse system. This is for day one. Now, coming to day 2, again we are getting the data in the day 2 in the e.text file only. Now, coming to second day, in this e.text file, again we are going to get the 3 records. But if you observe here, out of these 3 records, which records are new employee IDs, which records are the existing employee IDs? Try to do the answer. Coming to day 2, whatever the data we are getting, by seeing this data, you try to give the answer. Compared to day 1, which employee IDs are new and which employee IDs are the existing values?
4, 5 are the new.
4
One
and
is
5 are the new
One
employee
is
IDs, and one is
existing.
nothing but it's the existing value. Now, what we need to do here? We need to load the data from the this e.text file to the staging table on the day 2 only. Now, as we discussed earlier, or as we discussed yesterday, coming to day 2, in the staging database, we are going to load the data. But yesterday I given one statement. Staging database is always is a
Maintaining
truncate
current
and reload only. Staging database is nothing but always truncate and reload, or we can able to say every time we are going to perform delete and reload operation. On top of staging database, every time we are going to perform the truncate and reload, or we can able to call it as a delete and reload operation. What is the meaning of delete and reload? Coming to day 2, I will delete all these records. Just I am giving it in the red color for understanding. I am deleting all the records. Just I am representing it in the red color. Now coming to second day, we are getting only 3 records on top of your file. We will load only these records here. 4, 5, 1, D, E, A. And coming to location, we are taking the value as a Hyderabad, Chennai, and Vizag. So this is the way. Coming to day 2, in the staging table, we need to perform again data loading operation. But here we are going to perform everyday truncate and reload, or we can able to call it as a delete and reload. And for that reason, just for representation, I am showing you all these values in the red color, which is nothing but these records are deleted, and we loaded the fresh data into our staging table, which is going to contain 3 records, because on the day 2 in this e.text file, we are having the 3 records. We are loading all the 3 records into our staging database. Now you tell me, after loading the data into staging database on day 2, next what we need to do here? We need to load this data into our data warehouse table, which is nothing but in our employee dimensional table, I need to load the data. Now you try to give the answer. In this employee dimensional table, how we are going to perform the loading operation? Any guesses? First question. Are we going to delete this data, or we are going to maintain this data as is in the employee dimensional table?
We need to maintain the data.
We need to maintain the data. What's the reason? In the data warehousing tables, we have to maintain the current data plus historical data, because we are going to perform the analysis on top of your data warehouse tables only. For that reason, here we are not deleting the old records only, but here what we need to do, coming to day 2, whatever the records we are getting, we need to load all these records on top of your dimensional table. Now you tell me, for this 4 and 5, these are the new records or these are the existing records in the dimensional tables?
New records.
These two are the new records. For the reason, directly I'm going to load this data as is into my employee dimensional table. These two records we are loading directly on top of our employee dimensional table. But what about this record? You try to give the answer now. Coming to one, is it an existing record or is it a new record? Coming
It
to
should be
one,
updated.
this is the existing record on top of your employee dimensional table. But if it is the existing record, why this record is coming one more time? If you observe, coming to location, for example, he transferred from the Hyderabad to Vizag location. That's the reason source system sending this data one more time only. Now with this data, we are having the location value called as a Vizag, which is nothing but in the dimensional table. Already we are having the value called as a 1. For this value, we are having the location called as a Hyderabad. Now what we have to do here is, I will update this value from Hyderabad to location. So Hyderabad to Vizag. I am updating this value from Hyderabad to Vizag only for understanding. I am giving Hyderabad value in the red color, which is nothing but for this record, we are not performing the insert operation. What we are doing here, we are performing the update operation. Day 1, it is having the value as a Hyderabad. But coming to day 2 load, what we are doing here, we are converting this value from the Hyderabad to Vizag only. This is the way what we are doing here. We are loading the data from the ODS to staging and staging to our data warehouse system. Now in the same way, you try to give the answer. Coming to day 3, what will happen? Coming to day 3, if you observe, in the e.test file, how many records we are getting in the ODS on the day 3?
Three
On the day
records.
3, we are getting total 3 number of records only. Now, if you understand the day 2 flow, by using that understanding, you try to give the answer. Coming to day 3, how we are going to perform the loading operation from ODS to staging and staging to data warehouse. First question, from the ODS to staging, whenever we are going to perform the loading operation, what we have to do here? We need to perform the truncate and reload. For representation, I am displaying all these records in the red color, which is nothing but these records are truncated. Now we need to perform the reload operation. As part of reloading, how many records we have to load here?
3.
All the records as is. So here I am loading E, A, B. And coming to location, we are loading it as a Hyderabad and Chennai and Vizag. So this is the way what we are doing here. Coming to day 3, we truncated the previous records or we deleted the previous records or we loaded the only fresh data. Now coming to day 3, we need to perform the data loading operations from the staging database to our data warehousing table. Now you tell me, in this table, how many records we need to insert, how many records we need to update?
No any inserted.
Records we need to update and one record need to
Just only update.
insert.
Only one record we need to update. If
Sir,
you
no,
see,
sir.
we go one by one
Records
only.
1 and 2.
6 record, 6 employee ID 6. Is a new record or is a existing record?
New
Is it-
record.
It's
New
a
record.
new record. So we are inserting this record as is into my dimensional table. Now what about one?
Two
It's a
records need
existing
to
record.
update.
Day 1 is a Hyderabad. Day 2, we updated this value as a Vizag. But coming to day 3, what's happening? Again, this employee transferred to the Chennai location. So what we have to do here? Now instead of Vizag, we need to update this value as a Chennai. Now just for understanding, I am giving this Vizag in the red color. So with this, we are updating the again employee ID 1 from the Vizag to Chennai. Now what about the 2? This is also the existing record. Earlier he is working in the Chennai location. Now he transferred to, for example, Vizag location only. So for that reason, we are updating this value from the Chennai to Vizag. This is the way we are loading the data for day 3. But if you observe here, in this whole process, what we are doing? First question, where data changes are happening? Where your data changes are happening?
Data warehouse.
On
Data
top of your,
warehouse.
no, before data warehouse, first where changes are happening?
ODS.
In your source system only. In the source system, day 1 we are getting some kind of data. Day 2 we are getting some other kind of data. Day 3 we are getting some other kind of data. Indirectly, day 1 is working in the Hyderabad. Day 2 one is working in Vizag. Day 3 one is working in the Chennai. Indirectly, in the source system, your data is changing. Now in this whole process, what we are doing here, we are capturing all the changes which are happening in the ODS system. Where we are capturing all the changes? All the changes we are capturing by using the table called as a employee dimensional table. whenever we are capturing all the data changes into your dimensional table, which are happening on the ODS system, such kind of dimensional tables only we can able to call it as a SCD tables, or we can able to call it as a slowly changing dimensional tables. And now try to understand the statement by using example. Try to understand the statement by using a dimensional table. In this example, by using employee dimensional table, what I am doing here, we are going to capture all the changes. What I'm doing here, I am capturing the changes, whether it's a new record or existing record. If it is a existing record, what is the change? Hyderabad to Vizag, Vizag to Chennai, all this is the changes, and we are capturing all the changes on top of your dimensional table. But why we are capturing all the changes here? In the ODS system, every day we are going to get the different kind of data. Whatever the different changes of data we are getting in the ODS system, that changes we are capturing in the employee dimensional table. Such kind of dimensional tables only we can able to call it as a slowly changing dimensional tables. Again, if you repeat the statement, by using a dimensional table, we are capturing all the changes which are happening on top of your source system. Now in this example, what is the source system? ODS. With the help of the ODS, you are getting all the changes. That data we are capturing in the data warehouse by using the dimensional table. Such kind of dimensional tables only simply we can able to call it as a slowly changing dimensional table. Okay. Any questions up to here? Please ask me. Now tell me, who is going to perform all these kind of loading operations in the real time as we discussed yesterday?
Engineer.
As a data engineer, it is your responsibility to perform the delete and loading and update operations. And now in the ODS system, who is maintaining all these kind of files every day?
Source system.
Our source
Source
system
scheme.
will maintain all this kind of data in the ODS. Now tell me in the real time where we can able to see the ODS?
In the
In the Unix server,
Unix system.
or in the SharePoint, or in the Google Drive, or any one of the location, we can able to see the ODS. From the ODS, we are loading the data to staging. From the staging, we are loading the data to data warehouse. But as part of this example, what we are discussing, we are capturing all the changes which are happening in the ODS to our data warehouse system in the dimensional table. If we are capturing all the changes in the dimensional table, such kind of dimensional tables only we can able to call it as a slowly changing dimensional tables. Okay. Still, if you are having any kind of questions or confusions on top of this example or on top of this definition, please ask me here.
A small doubt.
Yeah, please.
So, in the previous table, you told us from Hyderabad to Vizag, from Vizag to Chennai.
Yes.
So, are we maintaining the editing also? So, means the previous locations also are we maintaining?
Yeah,
or
very
only the
good
current
question,
location?
Andy. Yeah, very good question. Actually, here, as part of slowly changing dimensional tables, we are going to have the different types of the slowly changing dimensional tables. Within next 2 minutes, we are going to discuss about that one, Andy. So with that, you can able to get the answer for your question. Just wait for 2 minutes. Okay. Any other questions?
Sir,
Yeah, please.
In real time, will they mention it is a SCD1 or SCD2?
No. So far have we discussed about this is the SCD1 or SCD2? No, right? That is the one just I'm going to discuss now only. So actually here we need to understand in the slowly changing dimensional table, we are having the different types of slowly changing dimensional tables. We can able to call it as those type 1 SCD tables. And coming to next one, type 2 SCD tables. And third type of table we can able to call it as a type 3 slowly changing dimensional table. So like this, we are having the different types of slowly changing dimensional tables only. Type 1 SCD, type 2 SCD, and type 3 SCD. Now, if you observe here in this example, coming to one, what is the first location? Hyderabad. From Hyderabad to Vizag, he transferred. From Vizag to Chennai, he transferred at D. But if you see in this example, for the one, now what is the latest location we are having? For one, what is the latest location? Chennai. Okay. Now we are having the HR team. As a HR team, he want to understand how many number of times this employee one transferred. He want to understand how many number of times employee ID 1 is transferred. And now what we are doing here, just we are going to perform the update operation. Now in this table, for employee ID 1, how many records we are having? We are having only one record. If you are going to have the only one record, how we can able to understand how many number of times this employee got transferred? Can we able to understand? For this one, what I'm doing, first initially we are having the Hyderabad. On top of that, we are updating this value as the Vizag. On top of that, we are updating this value as the Chennai. Indirectly, in this table, we are not going to maintain the historical data, which is nothing but you are not having the Hyderabad data, you are not having the Vizag data. For employee ID one, you are having the only current data. But if you are going to maintain only the current data, what will happen? Then we cannot able to perform the proper analysis on top of this table. But as per the requirement, whenever we are going to maintain only the current data in the SCD table, such kind of tables only we can able to call it as a type 1 SCD tables only. Just form like this. As per the requirement, in slowly changing dimensional tables, if we are going to maintain only current data, if we are going to maintain only current data, such kind of tables we can call it as type 1 SCD tables. In the slowly changing dimensional table, if we are going to capture only the current data information, such kind of tables only we can able to call it as a type 1 SCD tables only. Now, what is the meaning of current data? Coming to 1, what is the current location? Chennai. Now, in this table, we are maintaining the only current location. We are not maintaining the previous location for Hyderabad and Vizag. Just as representing that in the red color. Indirectly, in this table, we are going to maintain the only current location of employee ID 1, which is Chennai. Now, coming to 2, what is the current location? Vizag. We are not going to maintain the history location. We are maintaining only the current location. Whenever we are capturing the changes, by considering only the current records only, such kind of dimensional tables we can able to call it as a type 1 slowly changing dimensional table. That is the definition. But what is the disadvantage of the type 1 SCD tables? What is the disadvantage
the previous data
of the type 1? Here, because of not maintaining historical data, we cannot able to perform proper analysis. Now, as for our example, HR person want to do some kind of analysis on the employee 1. He want to understand how many number of times this employee got transferred, but we are having the only current location. By seeing the current location, we cannot able to find out what is his previous location. Indirectly, on top of this table, my HR team cannot able to perform any kind of analysis only. That is the disadvantage on top of your type 1 SCD table. But forget about the disadvantage. Try to understand what is the meaning of the type 1 SCD table. And here we are capturing all the changes which are happening on top of your source system. But as part of doing this capturing, we are maintaining the only current data. If you are maintaining the only current data in the dimensional table, such kind of dimensional table simply we can able to call it as a type 1 slowly changing dimensional table. Okay. Any questions up to here? Please ask me. Someone asked the previous question, sir, in this table, are we going to maintain the historical data? We are not going to maintain the historical data in this example or in this table only. You are not having the Hyderabad record. You are not maintaining the Vizag record. You are maintaining the only record for 1, which is nothing but Chennai location, which is nothing but we are not maintaining the historical data in this dimensional table. That's the reason this kind of slowly changing dimensional table, we can able to call it as a type 1 slowly changing dimensional table. Okay. Now you tell me, if you want to overcome this disadvantage, compulsory what we have to do? If you want to overcome this disadvantage from the HR team side, what we have to do? We need to maintain current data and also we have to maintain the historical data only. Now we can able to say, as per the requirement in SCD table, if we are going to maintain current data and also historical data, such kind of dimensional tables we can call it as type 2 slowly changing dimensional tables. What I'm telling here, in the dimensional table or in the slowly changing dimensional table, if we are going to capture current data and also if you are going to maintain the historical data in the slowly changing dimensional table, such kind of dimensional table simply we can able to call it as a type 2 slowly changing dimensional table. Now you tell me, whatever the example we discussed here so far, this is the type 2 dimensional table or this is the type 1 slowly changing dimensional table? This table is falling under type 1 or type 2. This is the type 1 only, because in this table we are capturing all the changes, but we are maintaining only the current data. For that reason, this kind of slowly changing dimensional table, we are calling it as a type 1 slowly changing dimensional table. Now we'll try to understand how we are going to maintain the data in the type 2 slowly changing dimensional table. See the second example. If someone is trying to ask the question, can you please continue? I muted all the people. Can you please unmute and ask the question?
Sir, we are in data warehousing, in architecture in data warehousing, we are maintaining the current and previous data, right?
Yeah, we have to
So
maintain the
when we-
current and historical data.
historical
But
data.
if you are, so that's the thing I'm telling you. So if you observe here, in this table, if you see coming to day 3, this is the only one record we are getting from the source. But what about this, all these 1, 2, 3, 4, 5 indirectly, what we can able to say? This 1 record or 2 record or 3 record or 4 record or 5 record, this data is loaded on the day 1 or this data is loaded on the day 2. Indirectly, you are going to have the day 1 data plus day 2 data plus day 3 data. But here we are not having the current location or we are not having the current value on it. Try to understand the statement. In this table, you are having the day 1 data, you are having the day 2 data, and also we are having the day 3 data. But we are not maintaining the current values on top of this table. That's the reason we are calling it as a type 1. Okay. But as per the definition of data warehouse, we need to maintain the current data plus historical data. Now what we are doing here, just we are discussing about the one of the type of the table called as a SCD table. In the SCD table, if we are going to maintain the only the current values, such kind of tables we are calling it as a type 1 SCD. But you tell me, as per the definition of data warehouse, in the real time, are we going to see the type 1 SCD tables or we are going to see the type 2 SCD tables in the real time projects? In the real time projects, we are going to see the type 2 SCD tables most of the time study, because in the data warehouse, obviously we have to maintain the current data plus historical data. But in which type of slowly changing dimensional table, we are going to maintain current data plus historical data in the type 2. That's the reason, if you are going to work in the real time, obviously we are going to see the type 2 slowly changing dimensional table. But in some of the projects, there are the chances we can able to see the type 1 SCDs also. Or in the interviews also, they will ask sometimes questions and what is the type 1 and what is the type 2. For that understanding, I given this example only for understanding purpose. We are discussing, we are maintaining the only current location. But if you are going to work in the real time projects, most of the times we are going to work on the type 2 SCD. In the type 2 SCD, obviously we are going to maintain current data plus historical data. Is it clear?
Yeah, sir, but yesterday we discussed architecture, right? In that we are having data warehouse. Inside the data warehouse, we are maintaining these type SCD.
Yes, correct. So that's again here also mentioned the same thing, right? So see, we are discussing about the dimensional tables, right? Where we can able to see the dimensional tables or fact tables only in the staging database or in the data warehouse component. Where we can able to see the dimensional tables and fact tables in our entire architecture of the data warehouse. In the ODS, obviously no, because in the ODS we are having the source files. In the staging database, here we are going to see the normal tables, because here just we are performing the kind of data conversions and we are performing the truncate and reloads only. Now, where we can able to see all the dimensional tables and fact tables in the data warehouse component, because where we are maintaining our dimensional modeling in the data warehouse. Okay, don't forget about the basics. These are the basic things already we discussed yesterday and today. So we are maintaining all our dimensional modeling in the data warehouse component. In the dimensional modeling, we can able to see the dimensional tables and fact tables. By considering all these statements, you try to give the answer. This dimensional table, where we can able to see in the staging database or in the data warehouse system. In the data warehouse system, we can able to see this dimensional table. Not only this one only. Earlier we discussed about the conformal dimensional table. After that, we discussed about the junk dimensional table, where we can able to see all these conformal dimensional tables or junk dimensional tables only. All those tables we can able to see in the data warehouse component as part of our architecture. Don't get any kind of confusion. As part of data warehouse component, we are following the dimensional modeling. In the dimensional modeling, we need to maintain the dimensional tables and fact table. As part of discussing about dimensional table, we are discussing about the different types of dimensional tables like conform dimensional table, gen dimensional table, and now we are discussing about the slowly changing dimensional table. But where we are maintaining all these dimensional tables, obviously we are maintaining in the data warehouse component only. Is it clear? Okay. Any other questions up here? See, because of discussing these advanced concepts, don't forget about the basic concepts. Every time I'm saying that in the data warehouse only we are going to follow the dimensional modeling, which is nothing but in the data warehouse only we are going to maintain the dimensions and facts. And in the data warehouse only we are going to maintain the dimensional tables and fact tables. Now we are discussing about the different types of the dimensional tables, where we can able to see all these types of dimensional tables are in the data warehouse component only we can able to see all types of our dimensional tables. Okay. Yeah, someone tried to ask the question. Please continue.
Sir, here we have less number of values, so simply we find out existing values. In real-time projects, how can we find out?
Yeah, you tell me. In the real time, are we going to perform all these activities manually, or we are going to use the tools for the purpose of doing these activities? In the real time, we are going to use the tools study with the help of the tools, and by writing the code, we are going to perform all these activities. In the Excel sheet, just for understanding, we are changing all the values and we are performing all the operations only. But if you are going to work in the real time, are we doing all these operations manually, or with the help of the tools, or with the help of the code, we are going to automate the process? With the help of the tools or with the help of the code, we are going to perform all these load activities and all these kind of data changes activities. And here in the Excel sheet, just for understanding, I am doing the modifications manually, but don't think that in the real time we are going to perform all these changes manually. For the purpose of doing all these operations automatically, we need to build the code. With the help of the code only, what will happen? All these kind of changes will happen as part of our real time projects. Okay. Any other questions before going further? Okay. Now see here. Yeah, please. Yeah, please. Your voice is very low only. Your voice is very low. Can you please speak a bit low?
Sir, am I audible now?
Yeah, audible.
Sir, am I audible? Yes. Sir, this Hyderabad, Vizag and Chennai. Is this locations you are going to maintain a separate table? This historic table?
No, so all this data we are maintaining in the same table, same dimension, single dimensional table only we are going to maintain all the values. Okay, just for understanding, instead of deleting these values, I am giving these values in the red color. Actually, what will happen is in this table, actually, we can able to see the data like this. Okay, but if I'm going to delete, what will happen? After sharing this Excel sheet, if you want to revise the thing, you can able to get the confusion. Where is the Hyderabad? Where is the Chennai? That's the reason. Just I'm representing all the deleted values in the all the updated values in the red color. Please continue.
But as part of type 2 SCD, we are going to store the historic values.
No, 1 second. So far, we have discussed about the type 2 only. So this entire thing on the type 1, because of asking the questions, I have not yet started on the type 2. So below example is for the type 2 only. So there I will, in detail, will discuss about how we are going to maintain the data in the type 2. We'll discuss about it. Just wait for 2 minutes. I will discuss how we are going to maintain same data in the type 2 slowly changing dimensional table. Okay. Any questions on the type 1, please ask me. Okay. If no questions, Andy, so what you can do here is, after completion of this class, I will share this Excel sheet with you. Please perform the same operations, whatever I did in the Excel sheet as part of the class, Andy. You repeat the same operation in the Excel sheet after completion of the class. In the type 1, how data 1 data is loading, how day 2 data is loading, how day 3 data is loading. Please try to fill this information. Indirectly, whatever we discussed in the above table, same thing you have to repeat again in this table. With that, what will happen? You can able to recap or you can able to re-understand what we discussed on top of the type 1 SCD. For that reason, just I copy pasted the same tables again one more time, but I given all the values as a empty values only. After completion of the class, I will share this Excel sheet. By using this Excel sheet, you try to recap day 1, what is happening, day 2, what is happening, day 3, what is happening on top of our type 1 SCD table. With that, you can able to recap whatever we discussed as part of our today's session. Okay. Now we'll try to focus on the type 2 SCD only. As I told you, what I'm doing here in the type 2 SCD, we are going to maintain the current data plus historical data. Now we'll try to understand what is the meaning of current data and what is the meaning of the historical data, and we'll try to understand how we are going to maintain that data on top of your type 2. Now tell me, for this type 2 dimensional table also, from where we are going to get the data? From the ODS only, ODS day 1, ODS day 2, ODS day 3, we'll go one by one only. Now coming to day 1, we are going to get the data. Now this data where we are going to load? Coming to day 1, we are going to get the data. So where we are going to load this data? This data we are loading into the table called as the staging employee table. Now staging database is always truncate and reload. Now coming to day 1, we are loading the data into staging database. So we are going to load the values as a 1, 2, 3, A, B, C. Location as Hyderabad, Chennai, and Vizag. This is for day 1. Now what I will do here is we are loading the same data into the dimensional table. So this is for day 1. For day 1, there is no issue only. From the ODS, directly we are loading the data into the staging database. From the staging database, directly we are loading the data into the dimensional table. That is the day 1. Now you tell me what about day 2? From your side, ready to the answer.
4, 5 new records.
Now coming to
In
day
the
1,
staging,
coming
we
to
will
day
do
2, what we will do
replay.
here, first we are going to delete all these records only, truncate and reload, or we can able to call it as a delete and reload. First I will delete all these records. After that, I will load the fresh records. Here what the records we are going to load? 4, 5, 1. And D, E, and F. Coming to second time, we are getting total 3 records only. So we are loading all those 3 records into this table. First, we are performing delete operation. On top of that, we are going to perform the data loading operation. Now, in the staging table, we are having the only 3 records only. Now, from here, I want to load the data into the dimensional tables. Now, I am calling this is nothing but my type 2 slowly changing dimensional tables. What is the meaning of type 2 as per the definition? It is going to contain current data and also it is going to contain the historical data. With that statement, now tell me here in this table how we are going to load the data. Coming to 4 and 5, these 2 are the new records only. Directly we can able to load the data as is. These 2 are the new records, that is fine. But what about this record? What we need to do? We need to update the previous record or we need to insert this record again one more time. Any guesses? We need to update the employee ID 1 from Hyderabad to Vizag, or we need to insert this record one more time here. We have to insert this record one more time. Indirectly, instead of updating the previous record, what I'm doing here, I am inserting this record as again the one more record. And now if you observe here, coming to 1, what is the current location? Vizag. What is the previous location? Hyderabad. Now indirectly, like to what I'm doing here, I am going to maintain the current data plus historical data. For 1, previous location is Hyderabad. For this record showing that my current location is Vizag. This is the way in the type 2 slowly changing dimensional table. We are going to maintain the current data plus historical data. Now you tell me, are we going to maintain current data and historical data in the same table or in the different tables? Earlier someone asked the question, are we going to maintain current data and historical data in the type 2 table in the same table or in the different table? In the same table, we are going to maintain the current location. At the same time, we are going to maintain the history location. Now tell me, for 1, how many records we are having? 2 records. Because of having the 2 records, you are easily given the answer. This is the current location. This is the previous location. Now, for example, in this table, for employee ID 1, I am having the 100 records only. Then how you can able to understand which is the current record or which is the previous record? Is it possible? Here we are having the very few records. Because of the reason, easily we can able to say this is the current record, this is the previous record. Now, for example, I loaded the data for day 3, day 4, day 5 like that. I loaded the data for 100 days only. After 100 days, for employee ID 1 in this table, we are having the 50 records only. Now, out of these 50 records, I want to understand what is my current record. How I can able to understand?
Sir, both e-names also different, sir. A, F.
It's my mistake. Just I will give it as same.
Time, sir.
Now see here, for the purpose of overcoming this problem statement, first we'll try to understand what is the problem statement here. Problem statement is, because of having current and historical data, it would be difficult to find out what is the current record. So what is the current record? It would be difficult to find out only. So to overcome this issue, what is the solution is? we are introducing one column called as a flag indicator column. So what we are going to do here, simply we are introducing one column called as a flag indicator column. In this table, I am going to maintain one column called as a flag indicator column. By using this flag indicator column, you can able to understand whether the record is a current record or the record is a old record only. Now indirectly here, I will add one column here, which is a flag indicator. Now coming to first day, what we can able to say on day one, this is why. This is why and this is why, because on day one all these are my active records only. For that reason all these values we can able to give it as a y. Now coming to second day, these two records are we are loading it as a new value, so for that reason we are giving it as a y and y. Now you tell me, for this employee ID 1, what are the changes we need to perform in this whole table now? You tell me, any guesses?
So we need to make the active flag as n for the record EID 1.
Yes, correct. So see here, for Vizag location, I am given the flag indicator value as a y because this is my current location. Now for Hyderabad, what we have to do here? This value we need to change it to n. So instead of y, we are going to update this value as a n. Okay. Now with the help of the flag indicator, easily we can able to understand what is the current location of y and now for example, if you want to frame the query, what is the query we can able to prepare? Simply we can give it as select star from EMP underscore dimensional table where employee ID is equal to 1. Now you tell me, if I am given the only employee ID is equal to 1, what will happen? You will get the two records in the output, but my requirement is I want to get the only active record. Now what is the condition we need to apply? Flag underscore indicator is equal to y. If I'm given the flag indicator is equal to y, automatically what will happen? It will display only one record, which is nothing but that is your active location only. Because of maintaining the historical data and current data, it is difficult to differentiate what is the current record and what is the previous record. For that reason, what we are doing here, we are going to maintain one extra column called as a flag indicator column. In this flag indicator column, we are going to maintain values as y or n. Here, y representing active record, n representing inactive record or old record. That is the meaning of the y and n and d. So coming to y, for 1, Vizag is the active location. Coming to 1, Hyderabad, this is the old location, also inactive location. For that reason, this value we are giving it as a n and this value we are giving it as a y. Okay. Now in the same way, if you understood all this concept only, now you try to do the answer. Coming to day 3, end to end, how we are going to load the data. Try to do the answer from your side. Day 3, how we are going to perform the data load operations. First step, in the staging database, what we will do?
First, you have to insert all.
Truncate and reload, which is nothing but first we are going to delete all the records. After that, we are going to perform the loading operation. Now here, how many records we are going to load? Day 3, we are getting total 6 records only. We are loading the values as simply like this. And locations are Hyderabad, Chennai, and Vizag. So this is the way you are loading the data into the staging database by deleting the day 2 records, and we are loading the only day 3 records on top of your staging database. And now you try to do the answer in this data warehouse system. How we are going to load the data? We'll go one by one record only. First record, employee ID 6. What we will do?
We will insert.
It is direct insert. Now what is the flag indicator for this?
Y.
Y.
Okay, perfect. Now what about employee ID 1?
We will insert.
We are inserting or we need to update?
No, we will insert. We will update only flag indicator for the previous record.
Perfectly correct answer. So we are inserting this record 1A Chennai as a new record. But for this record, already we are having the previous record as a Vizag. Now tell me here, Chennai is the current location or old location?
Current location.
Chennai is the current location. So we are giving value as a Y.
Y.
But coming to 1, what is the previous location Vizag? Now for this Y, what we have to do?
Yeah.
We need to make it as a just for understanding. I'm giving this in the red color. So this is the way we are going to capture the data for the employee ID 1, or this is the way we are capturing the data for the existing records only. In the same way, you try to do the answer. What about the 2?
So 2 also will insert and will update the flag indicator.
So see here, this also we are inserting, but this is already existing record. Now Vizag is the active location. Now Chennai will become as an inactive location. So for that reason, here we need to update this value as a n, and just for understanding, I'm giving this record as a red color. This is the way you need to understand how we are going to capture the data. Now you tell me in this table whether we are having the current record and history records or not. We are having the current data. At the same time, we are going to maintain the history data on top of your type 2 SCD tables. And the type 1, we are going to maintain only current data. But coming to type 2, we are going to maintain the current data and also we are going to maintain the historical data. But to differentiate the current data and historical data, what we are doing here, we are going to maintain the one column called as a flag indicator. In the flag indicator, Y is representing the active records, N is going to represent the inactive records. And this is the way we need to understand how we are going to maintain the data in the type 2 slowly changing dimensional tables. Okay. Now in the same way, as part of the solution, we are having the one more solution called as a versioning concept, which is nothing but instead of flag indicator column, we are going to maintain one new column called as version. Now in this column, we are going to maintain values as 1 or 0. Here, 1 representing active and 0 representing inactive. Now you tell me, is there any difference between the flag indicator and versioning? Both are completely same. And the only thing is nothing but in the flag indicator, we are giving the values as a Y or N. But coming to versioning, what we are doing here, instead of Y or N, we are giving the values as a 1 or 0 only. So this is the way simply we can able to understand one more approach to differentiate the current records and history records. Indirectly here, we are going to maintain one column called as a version column. Now, if you understand, coming to day 1, what's the values we are going to get for version? For day 1, what is the value we are going to get for all the versions?
0.
Now see here, 1 is the active, 0 is the inactive, which is nothing but here we are getting all values as 1. 1 is the active. Coming here, I am discussing about the day 1 and D. Again, we are discussing for day 1, day 2, day 3. First day we are loading the data. Coming to day 1, what will happen? All these values will populate as a 1. Now coming to day 2, these 3 records we are inserting. Now all these 3 values will become as a 1, but this value will become from 1 to 0 because coming to day 2, now this record is becoming as an inactive record. For that reason, we are updating this value from the 1 to 0. Now coming to day 3, what will happen? We are loading all these 3 records only. Now here we are going to maintain all these values as 1. Now this value will become as 1 to 0. At the same time, this value also will become as a 1 to 0. Indirectly, whatever the active records we are having, those records we are making it as a inactive record. After that, we are going to perform the data loading operation. This is the way simply we can able to understand what is the versioning only. But tell me in the real time, are we going to use both the columns or we are going to use any one of the column?
Anyone.
We are going to use any one of the approach, but we are not sure in which kind of projects, what kind of columns they are going to use. For the reason, I am trying to cover all the approaches from the real-time perspective. Either we are going to maintain the flag indicator column or we are going to maintain the versioning column only. With that, we are going to find out what is the active record and what is the inactive record. Now, other than these two options, we are having the one more option called as nothing but start date and end date. So this is the one more approach, and we are going to maintain the start date and end date columns. By using these columns also, we can able to differentiate what is the current data and what is the historical data, or we can able to call it as effective date and end date. In some projects, we are calling it as a start date and end date. In some projects, we are calling it as a effective date and end date. This is the one more approach to understand what is the current record and what is the previous record. Indirectly here, I will give 2 columns now, start date and end date. So what we are doing here, we are going to maintain the 2 extra columns. If you want to differentiate what is the current record, what is the previous record, one is the start date column and other one is the end date column. Now you try to give the answer from your side, any guesses? What is the meaning of start date? What is the meaning of the end date?
Start date prehistoric.
Start date is nothing but when this record is loaded. End date is nothing but when this record is updating. And that is the way we are going to capture the start date and end date. Now, for example, if you see for day 1, what is the date we are having? For example, here 2017-01-01. This is the date. On this date, we are loading the data, which is nothing but I have given the start date as 2017-01-01-01-01-01. For all these 3 records, I am given the start date as a 2017-01-01. Now you tell me for the day 1, what would be the end date? Any guesses?
10, 2017-01-10.
How you can able to say 10? I am talking about only day 1.
Both start date and end date should be same.
Both are
sir.
same.
Okay.
No,
No, it's a
see here
default
what will
date.
happen is in the
No
end
end
date,
date.
if there is no end date, we will give default value. What is the default value we will use in the real time is say 999 12 31. Okay, this is the default value which we are using as part of our real time process. And whenever we don't know about the end date, indirectly try to understand like this: 2017-01-01, employee ID 123 are joined. Now on the start date, can they able to find out what is their transfer date? They don't know when they are going to transfer, right? Indirectly, they don't know about the end date. And whenever we don't know about the end date, here we are going to provide the default value. What is the default value we are going to provide here? Simply we are giving it as a 9999-131. This is the default value we are going to provide. For all these three records, we are going to provide the same default value. And now you try to give the answer. What about the date? Date is nothing but, for example, 2017 January 10. What will happen here? For these records, we are giving start date is nothing but 2017-01-10. Coming to day 2, we loaded total 3 records. For all these 3 records, we are giving it as a same date value. Now, what about the end date for these 3 records? On day 2, what about the end date for these 3 records?
Same 31
Same
12.
31,
Directly,
12.
these are the active records, so we can give it as a 31 12 9999. That's it. Or we need to perform any other operation here.
So for the record 1, we need to give the.
Now see, coming to after loading the data for the day 2, one is transferred from the Hyderabad to Vizag location. Now indirectly for one, you know about the end date and that end date value we need to update here. Just here I'm putting that value. So what is the end date we need to give here now? This is the date we have to provide. Just we need to update this value. So just for the space purpose, I'm giving this value in the other cell. Don't assume that we are going to maintain the one more column. And in the same column, we are updating this value from the end date to your current date. Here we have to give it as a this is the way 10/01/2017. So this is the way we need to provide the data. So indirectly, what is going to happen? Whenever a record is becoming as an inactive record, we need to make that value from default date to the updated date. That is the way you can able to understand which is the active record and which is the current record. And now you try to give the answer. For example, if I am going to maintain the start date column and end date column in this table, now if you want to find out only the active records, and what is the query we need to frame? Any guesses? I am going to maintain only start date column and end date column. In that situation, if you want to find out what is the active record, what is the inactive record, or my requirement is I want to find out what is the active record of the employee ID 1, then what is the query we need to prepare?
Yeah, end date is equal to 31/12/19.
That's perfect. So we have to give it as a end date is equal to 31/12/9999. Because whenever we are seeing this value, that record only we can able to call it as a active record. Other than this, if you are seeing any other values only, that record we can able to call it as a inactive record. For that reason, if you are using the flag indicator, we are given the condition as a flag indicator equal to y. If you are giving it as a version, we are given the condition as a version is equal to 1. But if you are using the start date and end date column, then what we will do here? Here we are given the simply condition called as a end date is equal to 31/12/9999. With that, you can able to fetch the active record. And this is the way, by depending on the type of the column we are going to maintain, you have to change your queries by depending on the requirements. Okay. Now in the same way, you try to do the answer. What about the day 3? For day 3, we are loading data on 2017-01-20. Now you try to give the answer. What values we are going to get in the start date and end date?
Start date will get 20 as a start date and end date is default date.
For all these 3 records, we are going to give the same start date because we are loading on the January 20, 2017. And now these 3 records are acting as a active records. For the reason, for all these records, we are giving it as a 998/1231. Other than this, do we need to perform any other changes? Now see, connected to he transferred from Chennai to Vizag. When he transferred? On January 20. For that reason, here we have to give the end date is nothing but Jan 20, and we need to make this value as a update. And instead of 998/1231, we are making this value as a 20/01/2017. At the same time, do we need to perform any other change?
For the record 1.
This record 1, earlier he is working in Vizag, now he transferred to the Chennai. So for the reason, for this record also, what we have to do here, we need to update this default value from 10/9/12/31 to 2017-01/20. With that, you can able to maintain the current record and you can able to maintain the previous records only. Now, this is the way we need to understand. Day 1, how we are changing the end date. Day 2, how we are changing the end date. Day 3, how we are changing the end date. Now, you try to give the answer. What is the purpose of all these extra columns? That is the main topic you need to understand. Instead of these 3 columns, why we are maintaining all the remaining columns?
Data.
To understand what is the current record and what is the previous record, we are going to maintain all these extra columns. But tell me, are we going to maintain all these 4 columns or we are going to maintain any one of the columns?
Name one of the column.
Either flag indicator or versioning, or we are going to maintain the start date and end date only. In different projects, they are going to follow the different types of the approaches. For the reason, as part of the class, we are trying to cover all the approaches only. Either flag indicator or versioning, or by using the start date and end date column, we can able to differentiate what is the current record and what is the previous record. This is the way simply we can able to understand what is the type 2 slowly changing dimensional table. Now you try to give the answer. What is the type 1 SCD? What is the type 1 SCD?
It maintains only the current data.
It is going to maintain only current records only. So see here, because of discussing all these advanced concepts, please don't forget about the previous concepts only. In the type 1, we are going to maintain only current data. That's the reason here no need to differentiate what is the current record, what is the previous record. But coming to type 2, what is going to happen? We are going to maintain the current data plus historical data. That's the reason we need to differentiate what is the current record and what is the previous record. To differentiate that, we are going to maintain the flag indicator, or we are going to maintain the versioning, or we are going to maintain the start date and end date columns only. This is the way we need to understand how we are going to maintain the data in the type 2 slowly changing dimensional table. One more important thing, if you observe here in this type 2 dimensional table, employee ID column is a kind of a primary key column. Primary key column should not contain the duplicate records, but if you observe in this table, employee ID column is going to contain what? 1, 1, 1. Indirectly, it is going to contain the duplicates only. Now, to overcome this issue, in the type 2 dimensional table, we are going to maintain one more column called as a surrogate key column. In this surrogate key column, we are going to maintain all the sequence values like this. What we are doing here, to overcome the duplicate issues on top of your primary key column, we are going to maintain one more extra column called as a surrogate key column only. In this surrogate key column, what we are doing simply, we are going to maintain all the sequence values on top of your surrogate key. Again, this is the one of the exam question. They will ask a question like this. What is the purpose of surrogate key? Simply we can able to say, in type 2 dimensional tables, because of maintaining current and historical data, we will get duplicate records in primary key column. To avoid the issue here, we are going to maintain surrogate key column by populating sequence values. So what I'm going to do here simply, we are going to add one extra column called as a surrogate key column. In this surrogate key column, we are going to populate all the sequence values. But tell me here, do we need to maintain the surrogate key column in the type 1 table? In the type 1, there is no issue with the duplicate records in the employee ID column. For that reason, no need to maintain the surrogate key columns on top of your type 1 slowly changing dimensional table. But coming to type 2, we are going to face the issue called as a duplicate issue on the EID column. To overcome that issue, what we are doing simply, we are going to maintain one extra column called as a surrogate key column. In this surrogate key column, what we are doing here, we are populating all the values as a sequence values only. This is the way end to end we need to understand what is the purpose of our type 2 slowly changing dimensional table. Okay. Now you try to do the answer here. What is the slowly changing dimensional table? That is the main topic, right? So by this time, might be you will forget about what is the slowly changing dimensional table. Try to do the answer. What is the SCD?
Update the current data plus history data.
Is the definition? This was here. As we discussed earlier, so we can able to say SCD is nothing but by using a dimensional table, if we are going to capture all the changes which are happening on top of the source system, such kind of dimensional tables we can able to call it as a SCD tables. Within the SCD, we are having the 3 types only, which are nothing but type 1, type 2, and type 3. Type 1 is going to contain only current data. Type 2 is going to contain current plus historical data. Within the type 2, we have to differentiate current record plus historical record. For the purpose of differentiation, we are going to maintain either flag indicator column or versioning column, or we are going to maintain the start date and end date columns. And in the end date column, if you don't know about the end date, then what we are doing here, we are giving the end date value called as a 999-1231. These are all the things we need to understand on top of our SCD tables. Okay, I know already we are 7 minutes over already, but if you have any questions, please ask the questions. Otherwise, we can able to wind up the session. In the next session, we'll discuss about type 3, and we need to discuss about the different types of the fact tables. And so far, we are discussing types of dimensional tables. In the same way, we need to understand different types of the fact tables. That topic also will cover as part of our next session. Yeah,
Sir, how to handle in the code, sir, to update the flag from Y to N or the versioning values from 1 to 0 if the record is already present? How to insert or update query I have to modify, sir?
Yeah, so if it is a new record, you have to perform the insert operation. If it is the existing record, you have to perform the update operation. How you can able to find out whether that is the existing record or old record only? You need to join staging table with the data warehousing table. So, for example, if 1 equal to 1 is, if it is a matcher record, the record is existing table, existing record. On top of that record, we are going to perform the update operation. Now, for example, if 2 is in the staging database, but this 2 is not present in the dimensional table, then what we can able to say, this is nothing but my new record. Such kind of records we are going to update. Indirectly, we need to apply the join between staging database table and dimensional table. As part of applying the join, if you are seeing the matcher records, that record we can able to call it as a existing record. On top of existing records, we need to perform the update operation. If the record is not available for such kind of records, we need to perform the insert operations. Is it clear?
Merge command will come out, sir.
Yeah, by using merge command, you can perform that operation. But
thank you, sir.
All the people don't know about the merge command. That's the reason I'm not using the merge command word only. But indirectly, I can able to say with the help of the merge or with the help of the join, you can able to perform this kind of operations.
So here, surrogate key and employee ID, sir. The primary key is employee ID. So if you're adding the surrogate key, what is the?
We are going to add the combination of both the columns as a primary key. So once we are going to add the surrogate key, what we are going to here, I will add the combination of both the columns. Now, if you observe here in the combination of both the columns, do we have any duplicates?
No.
It's a 1-1, it's a 6-1 only. It's not a duplicate record. In the combination of both the columns, we are going to maintain the primary key.
Okay.
So, flag indication, versioning, started ended. Which approach is the best approach?
This is the approach we are going to see in the real
Started
time. Just I will make it in the green color. In the real time projects, most of the projects are going to follow the start date and end date. But in some of the projects, we can able to see it as a flag indicator and versioning. But in most of the projects, we are going to see the start date and end date column approach. Yeah, please.
Pseudo column?
It's not a pseudo column only. It's a this column we can able to see the table. We are maintaining a separate column as a surrogate key, but in this column we are going to populate all the sequence values. It's not a pseudo column. It's a physical column only.
So while creating the table, we'll give surrogate key plus employee ID as a primary key.
Yes, correct.
Is SQL table and this table is different, sir?
See, whenever we are talking about the tables only, so that is the same tables we can able to see in the Teradata, or we can able to see in the SQL, or we can able to see in the BigQuery. Everywhere we can able to see the same tables.
But in SQL, we are not using these keywords as surrogate key.
It's not a keyword, it's a column.
Column. Okay.
Okay, this is our column name. Indirectly, in your project, if you are going to maintain one table called as a type 2 SCD table, in that table, you are going to maintain one column called as a surrogate key column. It's not a keyword only. It's a column. This is the column name. Okay, but if I'm going to call it as a normal column, you cannot even understand. That's the reason we are giving the column name as a surrogate key, and this is the concept we are having on top of your type 2 table. In the same way, flag indicator column is a keyword, it's a kind of a column name. This is the column name we are going to maintain in the type 2 dimensional table. Now in this column, we are maintaining all these values. In the same way, version is the column name, start date is a column name, end date is a column name, and all these are the column names. Now tell me, same column names can be able to maintain in each and every database or not? SQL you can able to maintain any column, Teradata you can able to maintain any column, BigQuery you can able to maintain any column, and try to understand the concept. Okay, don't think that these are the keywords only. All these are not keywords. These are the normal column names.
So these concepts are applied to SQL also?
Yeah, SQL also, but tell me, are we good? So what is the SQL? And SQL is nothing but it's a kind of a structured query language. We are applying the SQL on top of what? On top of your database, we are going to write the SQL queries. Now you tell me, staging database where we are maintaining? In the database. Data warehouse where we are maintaining? In database. If you want to communicate with the database, we are going to use a language. That language only we are calling it as a SQL. You need to ask the question like this. All these concepts are applicable for the different databases. I can able to say all these concepts are going to applicable for different databases if we are using the data warehousing projects. Is it clear? Or any questions, please ask me.
Sir, in the requirement document, will they mention this surrogate key?
Yeah, they will mention everything only. So whatever the points we are discussing. So for example, in your project, they are maintaining the flag indicator column. How you can able to understand in the project which approach they are following? In the requirement document, they are clearly mentioned that in this table, we are going to maintain flag indicator column to differentiate current record and history record. Or in this table, we are going to maintain the start date and end date column. For end date column, give the default value as a 99 and 1231. They will inform all this kind of information on top of your requirement document. Even surrogate key column also Nandi. In this table, this column is going to act as a surrogate key. For example, here I have given the name like this. Instead of this, I am given the name like this, x_id. Now you tell me in this table which column is going to act as a surrogate key. You cannot able to predict, right? That's the reason in the requirement document they will specify this xid column is a surrogate key in this table. Indirectly, what we need to understand in this xid column, are we going to get data from the source? No, you are going to populate all these values as a sequence values by default because this is the surrogate key. If you observe here, out of all these columns only, which column data is coming from the source? Out of all these columns, which column
Employee
data
ID,
is
employee
coming
name,
from the
and
source?
location.
Only employee ID, employee name, and location.
Okay.
What about the remaining columns?
We
Remaining
we are
column
populate.
data we need to populate. Okay, we need to populate by RN. We need to populate the start date and end date values. Indirectly, all these values are not coming from the source. Now they are given the column name called as a XID column. Now they are going to specify this column is going to act as a surrogate key. By seeing the statement, what you need to understand in this column, I need to populate the sequence values. To understand all this information, we are discussing about all these concepts as part of our classes. Indirectly, whatever the points we are discussing here, all this kind of information you are going to see in the requirement document. That's the reason only we are covering all these topics as part of our classes only. Otherwise, what will happen? If I'm not going to explain what is the type 2, what is the type 1, what is the surrogate key, what is the start date and end date, if you are going to work in the real time, by seeing the requirement document, you will get lot of confusions only. For that reason, I am trying to cover all these kind of concepts as part of our data warehousing concepts. Is it clear?
Yes, sir.
Yeah.
Sir, every day same schema of the file come or different schema?
No,
Because
every day we are going to get the same schema. If there is any changes in the schema, source team should have to inform to us. And they need to inform us before 10 days or 20 days only, because here we created the table like this. Suddenly they are adding one column in the source schema. How we can able to handle as part of data loading? It is not possible, right? Whenever they are going to perform any kind of changes on top of the source schema, source team should have to inform to the data engineering team 10 days before or 20 days before only. With that, we are ready with all the required changes on top of our tables. Then after 10 days, might be they are going to send the new schema files. With that, we can able to handle the data loads on top of your staging and data warehouse tables as part of our real-time projects.
We'll use these concepts in that enhancements projects also.
Yes, correct. Okay, any other questions or any confusions?
Look,
And
in this
I'm repeating.
section.
Just I'm repeating on this. So by seeing all these things, don't get the confusion. Why I'm trying to explain all these things? Because all these are important from the real-time perspective. That's the reason I'm trying to cover all these details only. Because of discussing more details, don't get any kind of confusion. Try to understand, try to utilize all these details to get the job and to survive in the real-time projects. Yes, someone is trying to ask the question. Please continue now.
In the location surrogate column, insert one empty column, sir. It seems a single table.
All these are okay. You want to set one. Any other questions? Okay. If no questions, that's all for today. Now one day. So we'll connect again with the 11 part. Thank you.